Rain, thunder and lightning. Learning objectives. Rain. Frictional electricity. Flow of charge. Thunder. Lightning. Benjamin Franklin's experiment. Rain. Rain is very important to the earth. It supplies earth with water, one of our most important resources. You know that rain is formed by warm air rising from earth and cooling in the clouds. But have you ever seen it happen with your own eyes? Now you can. Activity 15.1. Materials required: a quart jar with lid, tap water, and 4 or 5 ice cubes. I. Pour enough water into the jar to cover the bottom. Imagine the water is a lake or ocean. 2. Place the lid firmly over the opening of the jar. Think of the lid as the rainy cloud. 3. Put 4 or 5 ice cubes on the lid. The ice acts like the cool air found high in the Earth's atmosphere. 4. Wait 10 to 15 minutes. Observation: water drops have accumulated on the inner side of the lid. The warm air inside the jar rises, carrying moisture from the after at the bottom. On Earth, warm air carries moisture from lakes, ocean and other water bodies. As the air in the jar reaches the top, it cools because of the ice on the lid. Similarly, on Earth the warm air cools, the higher it rises in the atmosphere. When air cools, it drops the moisture it is holding. In the jar we see this moisture collects inside of the lid. On Earth, it is seen every time it rains. Thus you made rain. Rainy clouds. There are 2 types of rain clouds. They are nimbostratus. These are low, dark, usually overcast. These are associated with large areas of continuous precipitation. Cumulonimbus. These are the clouds which produce lightning, thunder, heavy rains, hail, strong winds and tornadoes. They are the tallest of all clouds that can extend 60,000 above the surface of Earth. They usually have large anvil-shaped tops due to stronger winds at those higher levels of the atmosphere. Frictional electricity. The word electricity is derived from the Greek word electron, which means amber. Thales, a Greek philosopher, 600 BC, noticed that when he rubbed a piece of amber with woolen cloth, the amber attracted to itself the lightweight objects. Thales thought that this property was particular to amber only. Today we know that many kinds of substances can be electrified by rubbing. Static electricity. When electric charges are produced through the friction of one material upon another, these charges are called static electricity. Static means stationary or at rest. Static charges. Most substances, when rubbed against another substance, release static energy in the form of electric charges, caused by the friction between the surfaces of the rubbing substances. In every case, equal amounts of opposite charges are formed. Only 2 types of electric charges are known to exist, and these are called positive, plus, charge and negative, dash, charge. Activity 15.2. Like charges repel. Take a polythene rod or a strip and a piece of duster cloth. Rub the polythene rod with the duster cloth. The polythene rod will acquire the negative charges, the electrons that will be released by the duster cloth. The cloth will be left with the positive charge only. Since duster is not a good conductor of electricity, the negative charge will come through the hand which holds the duster and will neutralize the positive charge of the duster. Now the duster will have no charge, it will be neutral. As a matter of principle, the like poles repel. Similarly, positive charge repels positive and negative charge repels negative. Activity 15.3. Unlike charge attract each other. Hang a piece of acetate strip which is charged positive. Now bring another acetate strip, which is also positively charged, close to the hanging strip. The hanging strip will move away from the unattached acetate strip. Since both the strips have the same charge, They will repel from each other. Now replace both the strips with polythene strips which are negatively charged. Repeat the process. You will observe the same results. Again the hanging strip will move away. This shows that like charges repel, and the unlike charges have tendency of attracting each other. Flow of charge. Conductors. Substances that allow electrons to pass freely through them are called conductors. When electrons are deposited on certain materials, electrons, can make their way freely in and out among the atoms. Conductors include such materials as iron, silver, copper, etc. Insulators. Substances that do not allow electrons to pass freely through them are called insulators. When electrons are deposited on certain materials, electrons, cannot move freely. They remain more or less on the same point on the material at which they are deposited. Hard rubber, mica, glass, and porcelain are good insulators. Induction. When an electric charge of one kind produces a charge of another kind on a nearby body when there is no direct contact, the phenomenon is called induction. Thunder. Thunder is one of the best phenomena of induction. It generally occurs on the days when there is more heat and humidity. It is caused by the rapid rising of the air. As the warm, damp air rushes upward, it is cooled by expansion. The water vapor in it begins to condense to droplets of liquid water. This condensation releases the heat and warms the air, further providing more strength to the rising air currents. The condensed moisture starts to fall through the mass of rapidly rising air. Friction with the air tears some of the drops apart into spray or mist. In this process, electrical charges are generated. Charges in cloud. The water drops falling to the lower levels of the clouds have a negative charge. The fine spray that rises to the upper levels has a positive charge. A rapid rising of the air as the warm, damp air rushes upward is cooled by expansion. The water vapor in it begins to condense to droplets of liquid water. This condensation releases the heat and warms the air, further providing more strength to the rising air currents. The condensed moisture starts to fall through the mass of rapidly rising air. Friction with the air tears some of the drops apart into spray or mist. In this process, electrical charges are generated. Polarization of charges. There occurs polarization of positive and negative charges within a storm cloud. The tops of the storm clouds are known to acquire an excess of positive charges and their bottoms acquire an excess of negative charge. According to the mechanism of polarization, frictional charging separates the two charges. Since clouds have millions of suspended water droplets and ice particles, they collide with the upward rising water vapors from the earth, evaporates. In the collisions, electrons in the rising water vapors are ripped off, causing a separation of negative electrons from a positively charged water. Lightning. Lightning is a natural phenomenon formed by electrostatic discharges through the atmosphere between two electrically charged regions. The polarization, as we saw, makes the positive charge to carry to the upper portions of the clouds, and the negative charging gravitating towards the bottom of the clouds. This polarization has an equally important effect on the surface of the earth. The cloud's electric field stretches through the space surrounding it and induces movement of electrons upon the earth. Electrons on the earth's surface are repelled by the negatively charged cloud's bottom surface. This creates an opposite charge on the earth's surface. This creates a favorable situation for lightning to strike. How lightning causes? We know that clouds build up positive charge towards higher reaches and negative charges towards the bottom. The charge on a cloud will induce charges of the opposite sign, plus and minus, on objects below it on the earth. As the charge on the cloud increases, the magnitude of the induced charge is on an object below it is increased until a spark jumps between the cloud and the earth to neutralize the charges. This discharge of spark is called lightning. How lightning strikes tall buildings. You have read that the bottoms of clouds are negatively charged. When these clouds pass over tall buildings, the distance between the roofs of the buildings and bottoms of the clouds is small. The negative charges of the clouds induce positive charge on the building roofs. The buildings are induced with negative charge at their bases, due to electric induction. The moist air of the atmosphere acts as a conductor and free electrons from the clouds move in the air towards the building. On contacting with the building, these electrons form a path for other charges of the cloud to rush towards the building. The building comes under the heavy rush of these electrons and catches fire. Sci facts: the total energy in a large thunderstorm is more than that in an atomic bomb. The Empire State Building in New York City is struck by lightning about 25 May every year. Lightning conductor. Shortly after Franklin proved that lightning was a form of electricity, he suggested that if metal rods were installed on top of buildings and connected by thick wires to the ground, any lightning nearing the structure would pass through the metal into the ground without harming the building. Generally, a lightning conductor is a thick copper strip fixed to the outside wall of the building. The upper end of the strip has several sharp spikes and the lower end is connected to a copper plate buried in the earth. The electrons gathering around the spikes during lightning are so numerous that they repel any negatively charged air particles which move upwards towards the clouds. This lessens the chance of a lightning strike on the building. Even if the lightning strikes the conductor, the electric discharge from the clouds flows down to the earth through the lightning conductor, causing no damage to the building. Benjamin Franklin's experiment. In addition to electricity, Franklin studied a number of other topics, such as ocean currents, meteorology, causes of the common cold and refrigeration. He developed the Franklin stove, which provided more heat while using less fuel than other stoves, and bifocal eyeglasses, which allow for distance and reading use. He made important contributions to science, especially in the understanding of electricity. Though it is not very clear whether Franklin, an American scientist, performed his kite flying experiment, but the experiment is associated with his name, which is believed to have been performed by him in 1752. Franklin made a silken kite using wooden sticks as its frame. He fixed a thin metallic wire along the central wooden rib of the frame, whose one end was put outside the kite frame by about 30 centimeters. He tied another end of the metal wire with the string of the kite. He tied a metal key with the end of the string he held with the help of a silk ribbon. On a stormy day, he set out to fly his kite. When the kite went up in the sky, he observed that the loose string got stretched due to the electric charge from the clouds. At this moment, he slightly touched the key and received a shock. Fortunately, the charge was mild, otherwise the shock could have been fatal. Through this experiment, Franklin proved that the lightning clouds carry electric charges. On the basis of this experiment, he provided the principle of lightning conductors for the safety against the devastating effects of lightning. Precautions: never shelter under the trees during a thunderstorm or lightning. The lightning could strike the tree and could injure or kill you as it runs down to earth through the tree. It is best to kneel down in the open air with your head as low as possible and your hands resting on your knees with fingers pointing towards the ground. If the lightning strikes you, it should hit your shoulders, run down your arms and out of your fingers into the earth. This position protects your head and vital organs such as your heart, etc. Lightning, the useful side. Ozone from the clouds flows down to the earth through the lightning conductor, causing no damage to the building. Ozone protects from the hazards of ultraviolet rays coming from the sun. It filters the sun rays before they fall on earth. The evolutionary phases of life on Earth are associated with lightning, which is believed to have helped the process of evolution on Earth. Lightning has provided water to certain desert areas which got converted into green areas. Lightning may also improve air quality and clean greenhouse gases such as methane from the atmosphere. while creating nitrogen oxide and ozone at the same time. Sci facts. A lightning charge contains 30 million volts at 1 lakh amperes. About 100 US residents are killed by lightning every year. Benjamin Franklin's famous kite experiment in 1752 showed that lightning was electricity. Q keywords: accumulation, deposition or collection. Thunder, the roaring sound caused by the collision of clouds. Polarization, separation, disintegration. Friction, force making it difficult for one object to slide over another. Static, stationary or at rest, not moving. Summary. Rain is very important to Earth and is a natural resource. Rain clouds are of two types, nimbostratus and cumulonimbus. The word electricity is derived from the Greek word electron meaning amber. Static electricity means the charges produced by friction of one material over another. Static electricity is released in the form of positive and negative charges. Like charges repel and unlike charges attract each other. Substances that allow electrons to pass through them are called conductors. Substances that allow electrons to pass through them are called conductors. The phenomenon where an electric charge of one kind produces the electric charge of another kind without a direct contact is known as induction. Thunder is a best-known phenomenon of induction. Clouds have negative charges towards bottoms and positive charges on the upper sides. Polarization occurs within the clouds into positive and negative charges. Lightning is a natural phenomenon. It is caused when the charges of the clouds come into contact with the charge on the earth. Lightning usually strikes tall structures on earth. Benjamin Franklin proved that lightning is associated with electricity. Franklin suggested the use of lightning conductors on the top of buildings to save them from the destruction caused by lightning.